So dear student, today I will teach you how to do practical, virtual practical, because this is a pandemic situation and we are unable to do our digital practicals or analog practicals or technical practicals in laboratory. Now this time the best tool is the virtual tool, because virtually we can perform all those practical. Whenever we talk about the virtual practical, means practicals on the software, e-learning method via practical, so then one branch is struck in our mind, there is computer science, that is computer science, but we belongs from electronics and electrical background, so there are certain tools, certain software tools by which we can perform our practical. So now today I will tell you how to perform your practical on a multi-sim software. For example, let's suppose I want to do my digital electronics practical of checking the truth table of XOR gate, for example, as I have already been taught you in digital electronics, and you might aware about the XOR gate, that whenever both input are same, the output will be 0. The both input are same, output will be 0. Now how to check the practical in this pandemic situations, how to do the practical without the laboratory kit, without the practical kit. So multisim is one among the best tool to perform the practical. So now let's see. So first of all, I just show you a multisim screen. When we click on a multisim software after downloading it, screen will appear in front of you like the same. Yes, this one. Now here this is a multisim software. We have to perform the XOR gate. So first of all, go into place and component, then click on MISC digital. Yes, then MISC digital show you certain ICs, because we want XOR gate, so just click on XOR. Where is the XOR? Now see, check, find out the where is the XOR gate, and yes, so click on XOR and then OK. Then just left click on the screen. So now this XOR gate will be in front of you. So this XOR gate will be in front of you. Now the rest of the things are, we have to connect with this XOR gate to check the result. So first of all, for the current limiting resistors, we connect 100 ohm resistance at the input side as well as at the output side. So again click on MISC, then basic, because resistance, capacitance, the basic elements, switches, like these elements can be easily find in MISC. Then click on register. Then which capacity resistance you want? I want 100 ohm, so just type 100 over there and then OK. Then how many 100 ohm resistance you want? 300 ohm resistance, 2 for the inputs and 1 for the output. Okay. Now rotate them either, or if you don't want, no need to rotate them. I just rotate them, so it will looks like very good. So just right click and then rotate 90 degree, nothing else. If you want to move any resistance left or right, any component left and right, just left click over there and move your cursor, so it will be moved. Now left click at the one side of resistance and leave your left hand on from cursor after connecting where you want to connect it by clicking. Okay, so one input is connected with this 100 ohm, second input is also connected with this 100 ohm, and one output is connected with this 100 ohm. Okay, now 1 ohm resistance is also connected, because we directly apply the power supply. The general power supply is 5 volt, so 5 volt DC power supply we apply, so we also have to connect 1 ohm resistance at the input side and output side. So again go into basic, then register, then type which value resistance you want. I want 1k, so just 1k resistance. Okay, 3 times, 2 for the inputs and 1 is for the output. 1 2 no, not needed for the output, only the input we apply the DC power supply. at the output side we will find the result. Okay, so again rotate, if you want to rotate it by right click, then at rotate mark click left. Okay, so now connect one from the one input, okay, and second from the second input. Okay, now this 1 kilo ohm second points are connected to the ground. So click on mask again, then in source you will find out the power supply and the ground option. So ground, okay, how many grounds you needed? 2 for 1 kilo ohm resistance. Okay, you can short them also, but I use separate, and 2 for the another two inputs, another 100 ohm resistance, and one for the output 100 ohm resistance. Now how to connect? The 1 ohm resistance is directly connected with the ground like this and like this, and to show the input, what is my input here, which input is high, which input is low, and to show the output and to check the output, which out whether the output is high, whether the output is low, we connect here the LEDs. If LED glow, it means that particular terminal is high, and if LED is off, the means that particular terminal is not on. Yeah, there is no input at the, means zero input at that side. So go on mask, then you can type in all families LED here. Just type all families and type the LED, then you will see LED symbol or the, okay. So we use this kind of LED. Let's suppose this red LED is at the output side. Okay, so I connect a red LED, and this yellow LED is as one of the input I want. So this one is one input, and this green LED is second one input. Okay, so this one is second input. Okay, now the positive side is, the negative side is connected with the ground, so I just move this ground to connect with this. Like similar here, this negative side is connected with the ground, so I just move it, and the resistance is connected, that resistance value is connected with the positive side like this one. And if you are, yes, I just, yes, so it clearly looks like the positive terminal of the LED is connected with that particular 100 ohm resistance where you want to provide the supply. Similar to this green LED, now see one is connected with the ground, and the cathode is connected with the ground, and the anode is connected with the 100 ohm resistance of the input side. Similarly here, this cathode is connected with this, and the positive with the anode is connected with the 100 ohm resistance, and the cathode is connected with the ground. For the yellow LED, for the green LED, all LEDs. Okay, now to give the input, we first connected as two switches because there are two input terminals. So in basic you will find out the switch option. So in switch option, select any two terminal switch, one for the input side, one is denoted as A, so one is A, and now okay, so these are two inputs, one is A. By clicking over there we can on and off. Just if you want to change the name, you can change the name, otherwise not needed. Let's suppose this is your A and this is your B. Let's suppose this is your B. So one input is A, one input is B. Okay, now connect these two with the two terminal. One switch is connected with the first terminal, the second switch is connected with the second terminal. Okay, so whenever these switches are on, because we connect these both switches with the power supply, so whenever the switch is on, it means 0, means no input is given at that particular terminal, and whenever the switch is 1, means switch is connected with the power supply, it means we provide the 5 volt to that particular terminal. So now only the power supply is also we want to connect with the input terminal. So sources, then give in power source, then VCC, then OK. So this is your power supply. Now check. Okay, so I connect with the two input terminals. Now the whole circuit diagram to check the practical of the truth table of XOR gate is completed. With the help of this diagram virtually on Multisim software, we are capable to check the truth table of XOR gate, right? So now we check. For that we have to run. We have to run this one. So we just click on the either you type F5s or you click on run button. So now check what is the truth table of XOR gate. Whenever both input, one input is A, one input is B, when the both input are same, the output will be 0. So see, yellow LED is not on, green LED is not on, because both the switches are open. So there is no input. So at that time output is also not present, because red LED is also off. If we provide the first input, means yellow LED is on. See, if any input is 1, output is, if either of these two inputs, if one among the is 1, means high, then output will be high. See, the yellow LED is on, means this is off, this input is present. The green LED is off, this input is not present. So any one input is present, see, the output is also present. So red is also high. Now see, I switch off the yellow LED but switch on the green LED. So one input is present in the form of green LED, the second input is present, then also the red LED is glow. It means output is present, right? The first case was when A and B both are 0, 0. 0 means no LED on, means no input is there. So A and B both are 0. Then we checked that red LED was also off, means there will be no output. When yellow LED is on, it means first input A is 1, but green LED is off, it means B is 0, 1, 0. Then also output is 1. Then output is 1. If in this case yellow LED is off, it means A is 0, green LED is on, it means B is 1, 0, 1 case, then output is also 1. But now at the last case, when both input are 1, see, yellow LED is on, green LED is also on, means both input are 1, A is equal to 1 and B is equal to 1. At that time the output is also again 0. It means whenever the both input are same, either 0, 0, either 1, 1, whenever the both inputs are same, the output will be 0. So it is proved, and we proved it on Multisim software. So I hope you understand about how to work on the Multisim software, and even during this pandemic situations, how we can stop, how we, the electrical and electronic students can cross the boundaries for knowledge. Because on Multisim software, without the classroom study, the laboratory, we can learn our practical, we can check the results.